Okay, so welcome back. Now we're going to talk about a Type 2 series parallel circuit. And as we can see with a Type 2, we have now got a series circuit resistor, or a resistor in series, before the parallel portion of our circuit. So whenever we're confronted by this style of circuit, we need to calculate the parallel portion first. Okay, so in this case, I'm going to use the Bedmes method again. Okay, so 1 over RT equals, in brackets, 1 over 3 plus 1 over 4 plus 1 over 5. And now once we calculate all this, we have to add our series resistor on the end. Okay, so 1 over RT equals, in brackets. Okay, so we have 0.33 plus 0.25 plus 0.2 plus 2, which equals 0.783. Okay, plus 2. So RT equals 1 over 0.783 plus 2, which equals 1.28 plus 2, which equals 3.28 ohms. So that's our resistance total. Now, like any other circuit, we calculate our amperage total. So amperage total, we have 12.6 volts divided by 3.28 ohms, and that will give us 3.84 amps. Okay, so now we have our amperage total, we have our resistance total. Now comes the critical step in this style of circuit. We have to calculate our voltage drop over R1, and then we have to subtract that from our source voltage to give us voltage remaining to the rest of our circuit. So our voltage drop over resistor 1 is going to equal 3.84 amps times 2 ohms, which is going to give us 7.68 volts. So we're losing 7.68 volts over R1. So now we're going to calculate our voltage remaining, which is simply 12.6 volts minus 7.68 volts, and that is going to equal 4.92 volts. Okay, so what does that mean? That means we're dropping 7.68 volts across here, so at this point we have 4.92 volts now applied to the rest of our circuit for the rest of our calculations. Which means our amperage through resistor 2, okay, we are going to use 4.92 volts divided by 3 ohms. And that's going to give us 1.64 amps. Amperage through R3, 4.92 volts divided by 4 ohms, and that's going to give us 1.23 amps. Amperage through R4 is going to be 4.92 volts divided by 5 ohms, and that is going to give us 0.98 amps. Okay, so the key to these, and the key to the Type 3 as well, we have to calculate voltage remaining. Okay, it's critical. If we don't do our voltage remaining properly, the rest of our equation is not going to work. Okay, so step 1, resistance total of our parallel portion. Then we add our series resistor to it at the end. We get our total circuit resistance figure out our total circuit amperage, calculate our voltage drop over R1 or our series circuit resistor before the parallel portion of our circuit, subtract that from our source voltage, and we get our voltage remaining, which we apply to the rest of our circuit. That is the key to this type of circuit, and it wouldn't matter how many resistors we had, it would work the same way. So now, of course, the next step is going to be our power. I don't have much board here. We'll try to fit it in. So our power through our first resistor, we have 7.68 volts dropped across it, times our 3.84 amps. So we're going to get 29.5 watts. Power through resistor 2 now, our voltage drop across resistor 2 is going to be 4.92 volts times our amperage through it, 1.64 amps, and that's going to give us 8 watts. Power through resistor 3, once again 4.92 volts times 1.23 amps, and that is going to leave us with 6 watts. And then finally for P4, we'll do that over here in the corner, once again 4.92 volts times 0.98 amps. And that is going to leave us with 4.8 watts. Okay, so all of our calculations for that type of circuit. As you can see, it's not that difficult as long as we remember our key step, which is to calculate our voltage remaining. If we do that, the rest of the circuit should be fine. If we miss that step, it's not going to work. Okay, so we'll move on. Next video will be on type 3, which will combine this with the other type 1 type circuit, and we'll go through our calculations for that.